Welcome to this course on data mining. In this course, we're going to explore a number of different techniques for data mining. We're going to explain why data mining is important, and we're going to discuss using R how we can execute those techniques to find insights and value within the data for our organization. Now, the average salary for people with data mining skills is approximately $125,000. You can find advertisements for data scientists that will pay $128,000, or data engineering jobs that will pay an average of $115,000. There's no shortage of job openings for people who are looking to become data scientists. And data mining is one portion of what data scientists do. Almost 60% of all data scientists and analytics personnel are found in the finance and insurance industries, professional services, and information technology. But other industries such as healthcare and retail realize the value of data scientists, and it's creating this surge in demand. The annual demand for fast-growing new roles of data scientists, data developers, and data engineers will reach 700,000 by 2020 and possibly 1.1 million openings by 2024, according to the Bureau of Labor and Statistics. Now, what is data mining? Well, data mining is the process of discovering useful patterns and trends in large data sets by using a variety of statistical and computer science skills. So some of the areas of data mining will include things like your predictive analytics, machine learning, and artificial intelligence. And there are three ways that we can look at data science in general. We can look at data science in terms of descriptive analytics, predictive analytics, and prescriptive analytics. And each one has different facets about how they approach the data and what their ultimate objective is. Now, there are some tools that we use in data mining, such as relational databases like MySQL, SQL Server, Postgres, and Oracle, non-relational databases such as MongoDB and NoSQL, statistical applications like R, SAS, SPSS, and programming languages like R as well, Python and Java. And we use visualization techniques from Power BI, Tableau, Looker, R again, Python again, and the D3 JavaScript library. Now, there's something known as the cross-industry standard process for data mining. There are 6 phases, and this is a methodology by which we break down the data mining process. The first is a business research and understanding. We have to understand the business domain that we're in and understand how the data is going to lead to insights and value for the organization. The second phase is this data understanding. And the data understanding is to take a look at the data and understand the type of variables that we have and certain aspects of the data. For example, the range of the data, the frequency counts of the data, maybe its standard deviation, what the distribution is, and so forth. Because that's going to inform us about how we approach our analysis. Then we have to prepare the data. So we're going to prepare the data for data science techniques. What that means is to create subsets of data and possibly clean the data in a way that will allow us to get more value and more insights from the techniques that we're using. The techniques that we're using are part of the modeling phase because we're going to create a number of models associated with the question that's being asked. And it's really important to understand at this point that when we create models, you should not rely on one technique. You need to consider yourself a detective in terms of trying to ascertain what the end result is. We use multiple techniques because they each have sensitivities towards certain aspect of the data. And we'll talk more about that when we discuss modeling. And finally, we have the evaluation phase and deployment. Once we've identified the right models that we're going to use, we're going to evaluate it. We're going to determine, is this really saying what we're thinking it's saying? And then if it fits, we're going to deploy it in a way that the business executives and organization heads can actually use that information. Now, this is a generally tight cycle where we go from 1 to 2 to 3 to 4 to 5, and then we might go back to the business understanding or the deployment. However, I would argue that we need to change this a little bit because while historically this pattern is shown as a neat circular chart, it really doesn't occur like this. In general, the data mining is a discovery, and as such, data is analyzed and modeled, but the understanding of that data is also understood differently as you go through this approach, and things aren't as linear as they would appear to be. And so what we say is that at every single phase of our cycle here, we can go back to one of the previous phases. And what that is similar to is this OODA loop, the Observe, Orient, Decide, and Act loop that was originally presented by Colonel John Boyd of the U.S. Air Force. And what he says in this loop is that we observe our entire environment, we orient ourselves to that environment, and after we orient ourselves, we may have to get new observations before we proceed forward. But as we orient ourselves, we're going to decide what to do. But that decision is going to be influenced on maybe new orientations or new observations. And then again, after we act, the entire ecosystem is going to change. And so the OODA loop is not a circular loop. It is a constant interactive loop where things go back and forth. And that's a critical piece to data mining because the data scientist needs to be open to new observations and new things that occur and how the techniques are more sensitive to one thing or another. So I'm urging you to not think of this as a pure cycle, but as a very, very iterative set of interrelated steps that you can go back and forth and back and forth and back and forth without losing sight of the end goal. What are some of the activities in data mining? So there's description, estimation, prediction, classification, clustering, and association. And these are just some of the general activities. Now, in general, the first activity for any data scientist is to describe the data that's being examined. And this can be done through numerical analysis or graphical analysis. And identification of the nature of the data, such as the type of data or even identification of the distributions, is handled through these methods. So here we have an example of the IRIS data set, and we use the summary function in R on that data set, and it will provide us with information about each of the columns. So here the first 4 columns are obviously numeric, and if data is numeric in a data frame, it will give us the minimum, the first quartile, the median, the mean, the third quartile, and the max. If the data is categorical, then we will see, like here on the 5th column, species, and it will give us the number of each category within that column. Graphically, we can depict data in a number of ways. So if we have data that's separated into categories, we can actually use a box plot here to the left, where we see the differences in the different species of the irises in terms of their sepal length on the y-axis. In terms of continuous data, we can actually use a histogram, as we see here in the middle, where we have a histogram of the wind speed and the amount of records that have that particular wind speed or in that group. And finally, we can do a scatter plot in which we will actually look at 2 variables together to see how they relate to each other. In this case, total fertility and infant mortality by continent. Now, estimation allows us to approximate some value based on a number of independent variables. Estimation is based on the expected value of a dependent variable from the independent value. And you might be familiar with linear regression or multiple linear regression, which is one of the techniques in estimation. In a linear regression, we're taking a number of independent variables and we're trying to estimate what the dependent variable is. So y equals beta 0 plus beta 1 x1 and so forth. But we can use regression in a number of different ways based on the response variable's distribution. So in the case of a logistic regression, it would be that the dependent variable is a binary outcome, a yes or a no. In the case of a Poisson regression, we would actually have a dependent variable that followed a Poisson distribution. In the case of a rank or ordinal variable, we would actually use ordinal regression to actually predict the increase in probability of increasing in rank. And a beta regression would be used if we have a beta distribution for the dependent variable. And this is generally a number that would be a probabilistic measure between 0 and 1, but it also is based on the shape of the curve. Now, if we're doing prediction, that provides some future number based on information that the model has not seen. So we might be able to do this using classification and regression. So we'll predict a classification from certain variables, or we might predict a continuous variable from certain independent variables. And we can do that with a number of examples, such as predict revenue for the next 18 months, predict the number of orders in 4 weeks for better logistics, predict which customers are high-value customers as opposed to low values, and so forth. Classification activities are a form of estimation in which the response variable is categorical. In this case, we're attempting to identify which group an observation may lie, and we have different techniques associated with it. We can determine whether a transaction on a credit card is fraudulent, determine whether a customer will buy or not buy a product, determine whether a crime will be or will not be committed, and determine whether a student will rank as a 1, 2, 3, or 4 in their prospective grade. Here we have a chart to the right that shows different classifications. Now, clustering is a way to provide group observations based on their characteristics, whereas in the classification, we normally will have a classified model that we're trying to estimate or predict against. So it's a supervised learning model. We'll have some information already so that we can compute the expected value based on the independent variables. However, in clustering, we're not using that. We take our observations and we take all of the columns and data, and we will see how the data pulls on each other so that we can create a number of clusters based on those observations without knowing anything particular about what group or cluster they're in. And this is known as an unsupervised learning model. Clustering is not a classification because there's no target variables such as buy or no buy. So we're not really doing a prediction in that sense. We're just looking to group these observations based on those characteristics. The choice of the number of clusters is somewhat arbitrary, and it depends on what the analyst is looking to accomplish. In some cases, you might be looking for a high, medium, or low. In other cases, you might be looking for a straight 2-level classification of yes or no, fraud or no fraud. And sometimes you may want a little bit more, like a 5 levels, like a ratings of 1 through 5. Very high, high, neutral, very low, and very low. The chart to the right shows us a graphical example of clustering of states based on crimes. So this has about 4 crime variables inside of it, and we see how the states end up clustering together. We've chosen a 4-cluster solution here, and this is what the values look like. Association algorithms attempt to find which attributes are more inclined to go together. It uncovers the rules that quantify relationships to variables, similar to analyzing correlations of variables. It takes the form of the if this, then that, and the rules provide a level of confidence around those decisions. So, for example, an online pizza establishment will find that 200 customers that came to the online site, 100 purchased pizza on Monday evening, but 35 also purchased fried cheese sticks. So it has a support level of 50% and a confidence level of 35%. And we'll go through this more in the association modules. But this is widely used to understand basket of items, the association of buying this, then doing that, like beer and diapers. This is a classic one in marketing. It also can determine the confidence of purchases, of gathering items in a basket and then actually purchasing.